Hey guys, in this short video I'm just going to show you some of examples of how you can get positive and negative velocity. So we're going to start with this, the definition of velocity like this. This is equation 2.2 in Principles of Physics. It's the change in x over the change in t. Of course, we should keep in mind that when you do this in calculus you get the derivative form, which is dx over dt. We're going to be using that eventually, but at the moment don't need to worry too much about it. So when I write this Vx, what I actually mean is the component in the x direction of the velocity. In other words, I'm talking about this guy. We'll eventually talk about the whole vector, but for the moment we just want to worry about Vx, and so I'm saying that Vy is equal to 0 for the moment. The question I want to answer is, when is Vx positive and when is Vx negative? So to answer this, we'll give a little more detail about what delta x and delta t mean. So delta x is x2 minus x1, and delta t is t2 minus t1. Notice that actually some places, including in the textbook, this notation is used. This is x final minus x initial, but what I'm talking about when I write 1 and 2, I just mean the initial is 1 and the final is 2. So I'm talking about a point x1 at t1 and another point x2 at t2, with t2 being larger than t1. So t2 is later than t1. And so what that means, of course, is that xt is greater than 0. So the time interval is greater than 0. That's not always going to be the case, but this is really an assumption which we're going to use nearly all the time, because that's the natural way that we think about time. When you study more things about oscillations later in the semester, we may worry about, if we set time to be 0, we may want to worry about times that occur before 0, but for the moment, we're just going to say that delta t is greater than 0. So here I have the x-axis. I'm not including the y-axis because we don't have any y components here. And here are 2 points, x1 and x2. Now when you think of this could just be a number line of some kind, where x1 is now smaller than x2, or in other words, x2 is larger than x1. So that means that delta x is greater than 0. And if you look back at v being delta x over delta t, this means that Vx must be greater than 0. So this is going forward. So if you would define the axis like this, if a particle is advancing to a larger x, that means that it's going forward, and that means that the velocity is positive. In the other case, where we have this coordinate system where our initial position is further away from 0, and our final position is closer to 0, then we have the opposite. x2 is smaller than x1. That means that delta x is less than 0, which means that Vx is also less than 0. And so in this case, we can call this going backward. And so when a particle is going backwards from a further x to a smaller x, then the velocity is negative. So these are sort of just very rough terms, depending on what you think of as going forward and going backwards. But if you think of it relative to the coordinate system, then you get a very well-defined condition, which is that if x is increasing, then you have a positive velocity, and if x is decreasing, you have a negative velocity.